Continuing on with our discussion of annotating point plots with models, let's take a look at some examples of models. So first, let's not get too fazed by this word model. Let's think about some easy ways to understand this idea of what is a model. What do we mean by a model when we are talking about data? So here is a data set. It's got only 3 columns or 3 variables: height, weight, and gender. Obviously, the unit of observation is a person. Every row represents a person. The columns represent their height, weight, and gender. Okay? So now, suppose I tell you, here is this data set, and I say I picked a random person from this data set. So I picked any one of these people at random, and I tell you, guess their weight. Okay, I don't give you any further information about the person that I picked. I'm not telling you what their height is or what their gender is. I'm just saying I picked a random person, guess the weight. Okay, so then with no further information about the height or the gender, your best guess can only be the average weight. Okay, so all you can do is to say, okay, among all the people, I take the average weight. And when you pick somebody at random, the best guess I can do is, well, my guess is the average weight, which is 65.3. Okay, you cannot do better than this. Now, statisticians would prefer not to give a single number like 65.3. Instead, they would prefer to give a range like 65.3 plus minus 8.68. Okay, now we'll see more about this. How did I exactly come up with this number 8.68? Okay, we'll see more about that. But the reason why statisticians give a range, again, is something we have discussed earlier. After all, we only have a sample right here. Okay, if we repeated the experiment with a different sample, then you're going to get a slightly different number, like 65.3. Okay, you're going to get, this shouldn't be 56.62, it should be 65.3. You're going to get a different average if you repeated the experiment with a different sample. Okay, so but what we are saying effectively is that if you repeated the experiment many times with different samples, 95% of those samples will fall in this range, 65.3 plus minus 8.68, or alternately 56.62 to 73.98. The center of it is 65.3. Okay, that is what statisticians prefer, because we are always working with samples. We are never saying that this is the complete population. Okay, that's it. You just built a model to find the weight of a person randomly chosen from here, but your model had no explanatory variables. Right? In other words, we didn't say, well, given such a height and such a gender, this is going to be the weight. We didn't have any of that. We just said, this is a model to predict the weight with no explanatory variables. Okay, so here is again the same data. A model is nothing but a method to make a good guess about the value of a response variable given the values of the explanatory variables, if any. In this particular example that we just discussed, there was no explanatory variable. Okay, so what do we mean by a good guess? Well, we mean that if you repeated the experiment many times, then the guess that you made will be pretty close to that value every time. Okay, in other words, like I explained it earlier, your guess will fall in that range which we identified, the range that will contain 95% of the times you do the experiment. Okay, let's take a look at a model with one categorical explanatory variable. Okay, so same data. This time I say I pick a random person, guess their weight given that they are female. Okay, this time I gave you the gender as well. Last time I did not give you the gender. Okay, so this time your answer would be, well, if you told me that they're female, I can then go and calculate the average weight of the females and make that as my guess. Okay, and that happens to be 55 in this data set. So if you took all the females and took the average, it turns out to be 55. Okay, so that would be your best guess. Again, statisticians would prefer to give us an interval like 55 plus minus 5.94, which again says that if you took different samples and repeated the experiment many times, then the average weight would fall in this range 95% of the time. Okay, we'll see later more on how to calculate this range exactly, but that's the point that we are making. Okay, on the other hand, if I told you that the gender is male, then you would guess 75.6 because that's the average male weight in this data set, and you would give a range like 69.66 to 81.54. Okay, that's it. So you just built a model with one categorical explanatory variable. Okay, in other words, if I tell you that the gender is male or female, then you can make a better guess about the weight of the person who I randomly picked. Okay, let's take a look at a model with one numeric explanatory variable. This time I say, I've picked a random person, give your best guess of their weight. Oh, incidentally, this person is 170 centimeters tall. Okay, so I've given you their height and I'm asking you to guess their weight. I'm not telling you the gender. Okay, so in this case, we have one explanatory variable. Okay, and we need to find the weight. So this time your best guess would be 66.7. More precisely, the range would be 65.7 to 67.7. Well, how did we arrive at that number 66.7? Okay, so what we really do in this case is we make a plot, a point plot of the height versus weight. Okay, so you're seeing all the points here. Now what we do is we draw the line that is most close to all of the points. Okay, once again, this notion of what is most close, we'll talk about it shortly. Okay, but we pick the line that goes as close as possible to all of the points. Okay, no other line can be as close as possible to all of the points. This is the line that is absolutely closest. And we call that as the model that we are building. So now we've got a model, meaning it can help us to make a determination. So now you've told me that the height is 170 centimeters. So I put the height right here. And I draw a line from 170 centimeters height to intersect our model line. And then I draw a horizontal line. It intersects the y-axis at 66.7. And I say, well, for a height of 170, my model is predicting a weight of 66.7. Okay, that is because this is the line that best fits all of the points. Okay, so that's what our model prediction is. Okay, of course, statisticians are not going to be happy with just a single line. They want to give a range. So in that case, we develop a model with a band like this instead of a single line. Okay, and given the band, we can find the range for the model prediction. So again, we've got 170. We intersect it with the lower end of the model band, and the lower end says 65.7, and then I extend it up to the higher end, and again I draw the line, and the upper end is 67.7. So I say that my model prediction is in the range 65.7 to 67.7. That's the model range. Okay, so statisticians prefer to give ranges because, once again, if you repeated the experiment with different samples, you're going to get different averages. You're going to get different lines which make different predictions, but 95% of the time the prediction would fall within this range for a height of 170. That's what we are saying. Okay, so let's take a model for a quantitative variable versus a categorical variable. Okay, so this time there is a data set called beekeepers. It's really a data set about lung cancer, and I'm plotting the point YR, which is the number of years that people smoked, on the y-axis, with lung cancer on the x-axis. Okay, so we are seeing here, of course, the x-axis is categorical and the y-axis is numeric. So the y-axis has lots of points, but in order for us to be able to see all the points, they've jittered it. Okay, and then again we have said a not equals model, which means we are telling the system, don't just plot the points, but also show me the model. And when you ask it for the model, it's going to give you the model. But like we saw for the height versus weight, the gender versus weight example, the model is a range. Okay, so in this case, it says for a person who is a smoker, who has lung cancer, okay, you would say that the range that they would have smoked for this range of years, meaning suppose I gave you a person who had lung cancer and I asked you, tell me how many years did they smoke, then I would say, well, I would give you a range of this, okay, the lower end to the upper end. That's the number of years I would predict that they smoked. Okay, once again, if you repeated the sample with lots and lots of people, then 95% of the time that's where the value would fall. Okay, and if you gave me a person who's a non-smoker and asked me, who doesn't have lung cancer and asked me what is the number of years they smoked, I would say, well, I would put it in this particular range. Okay, that's because not all smokers get lung cancer, but the probability of getting lung cancer increases. And therefore, you can see that for people with lung cancer, the range falls higher than for people with no lung cancer, the range falls lower. Okay, so that's a model for a quantitative outcome variable plotted against a categorical explanatory variable. Okay, so the model comprises of two intervals, one interval for each level of the categorical explanatory variable, namely lung cancer and no lung cancer. Okay, just like in our previous case, we had the female and male gender as the explanatory variable. And for each of them, we saw the model. Okay, so that's just giving you an intuition for models. Okay.